So I thought perhaps we could have a little discussion about what is energy and what we might sort of come to understand it to be. So from a physics point of view, energy is literally the ability to do work. Energy means the ability to do work. And so that's very broad and it's very grey as to what that actually means. I mean, we sort of think that, oh, physics have got it nailed, but there's lots of different kinds of energy. And I would say that in physics, energy is like a collective term. It means different kinds of energy. So, for example, we've got chemical energy. So that's the energy. We could do work by, I don't know, combining chemicals and letting things fizz away in the lab. We've got thermal energy, heat energy, basically. We've got energy from when we heat something up or when we cool something down. There's energy that comes there. We've got electrical energy. We've got gravitational potential energy. We've got nuclear energy, all sorts of different energies that we can harness to do work. So in physics, it's a collective term. So I think that's very important to appreciate because when we start to look at what energy means in a more, I don't know, subtle, esoteric meaning, then I also think that energy is a collective term for different kinds. Like chi, for example, is a collective term for different kinds of energy. Mm. Now there was a an equation that was created in the early 20th century by Einstein, which I think it changed, absolutely revolutionized our understanding of energy. And after lots of machinations and calculations and scratching his head and things, Einstein was a total genius. He came up with this equation: energy is equal to mass times the speed of light squared. So E equals mc squared. So let's think about the implications of this. So he says that energy is equal to mass times a very large number. So the speed of light squared is just a number, very large number. So energy is equal to mass. And wow, I mean, that is absolutely profound when it comes to trying to understand. So material, matter, stuff, mass is energy. You could say it's like solidified or congealed or confined energy in material, right? So at that time, people were just starting to understand the quantum world. Like, there's been a few experiments in the late 19th century, but coming into the 20th century, there was a whole slew of experiments which were looking at the nature of matter. And I think up to then, people thought that an atom was the indivisible, solid foundation of all other materials. So if you cut everything up, divide it up, then the most indivisible thing, the tiniest thing, was an atom. You can't cut it. And then, of course, people discovered electrons and protons and neutrons inside the atom, and the fact that protons and neutrons are themselves made of other particles. But then when you start to look even deeper at these kind of things, you see that in the quantum physics world, that these, what we call particles, are not like balls. They're not like planets in orbit around the sun. Electrons do not orbit the center of the atom like a planet does. An electron, under some circumstances, behaves much more like a wave. So you could think a wave is like you look on the ocean, right? So you see these waves. So what is a wave? Well, it's kind of like a bit of a man-made concept. Okay, so I can say that's a wave and that's a wave, but can I say where a wave finishes? No, I can't. It just blends into the next one. And can you say what's a wave made of the on the ocean? Well, it's made of water. And how is it different to another wave? Well, it's all made of the same water. In a sense, it's not different from the other wave. So what defines one wave from the other? Well, you can see it's got a kind of peak to it. And then the other one's got another peak. So there's a kind of identity to it, but there's also a kind of part of the oneness, of the oneness of the ocean, part of the ocean. So the people looked at electrons, and then of course there's other things like protons and neutrons and all the rest of it. and they discovered and light particles as well, photons, and it discovered that these particles, what previously thought of as solid and divisible, were actually waves. They're behaving like waves, and it kind of spread out in space, and don't seem to have a definite edge, right? They don't have a boundary. So then you start to realize, so mass, what we think of as mass, as like solid things, as these kind of indivisible balls, actually are not really as indivisible and solid as you might imagine. So then a wave, that's much closer to our what we might visualize energy to be. A wave is energy. So then you start, okay, so Einstein said E equals M, energy is equal to mass. So that kind of makes sense, right? So energy, if you confine it down into a kind of peak of a wave, then you could say that's like a particle, right? In some circumstances, it certainly behaves like that. So energy is equal to mass. Mass is then energy equal to energy. So I can now take a piece of material, matter, and I can do certain kind of chemistry to it, and it'll get energy out, which totally makes sense. So if I could just transform that material, the mass, into energy. And actually, we now know we can do that quite efficiently. We can transform all of the energy of a piece of material into energy, like light or heat or something like that, through like nuclear reactions or something similar like this. So this is a profound understanding that energy is equal to mass. Mass materials is energy. And that's completely from the science and quantum physics world, like understanding. And I think it's allowed people to do all sorts of amazing things since then. Hmm. So please do just jump in, if you have any comments or anything like that. I think anything's coming up. So another thing I wanted to mention is when you look out into space, it's black. And there's this understanding that space is a vacuum. In fact, it's probably the best vacuum ever. We come nowhere near to being able to produce as much of a vacuum here on Earth as there is in space. So vacuum basically means there's nothing there. There's just no particles or very, very few. Right? So something like in the depths of space, there's like one hydrogen atom per meter cubed. It's so empty. So that's on the matter point of view, right? So there's no stuff in the depth of space, in between the stars and between the galaxies. But what people have found is that there is energy. And it's been termed the quantum vacuum energy. And I think it gets very, very misunderstood and it's very complicated. So I'm going to try and introduce it in such a way that feels. I mean, I struggle to get my head around it a bit. So let's see. So the quantum vacuum energy is energy that exists in the vacuum of space. And when people started to delve deeper into the quantum world back in the early 20th century, then they started to discover that because some particles behave like a wave, like they don't have a definite boundary, you can't really say like exactly where it is. It takes a spread of possibilities, right? So if it's in position or in speed or in momentum or something like that, you can't really say exactly how much it is. So then the whole world of what they call uncertainty came along. So previous to that, people were very certain this is that number or that number. Then comes along quantum physics, and then you get this kind of idea. Okay, well, it's spread out. There's a possibility here, or a spread of different numbers. So then there was a guy who came along and said, actually, there's a fundamental limit to the exactness that we can measure things. It's come to known as the uncertainty principle. It's a fundamental limit to the exactness, to the precision in which we can measure things. And at some point, it just becomes impossible to know for sure, like the exact position or the exact speed or something like that. So this uncertainty principle, this fuzziness, I suppose, in the in our precision, means that no quantum system, no system at all, can settle down into a perfectly zero energy state. Because of this uncertainty, there's a very small chance that something might be there, or there's some energy there. So you look at the vacuum of space, nothing at all. And because of this uncertainty at the very small level, it's very minuscule, but there is an uncertainty. There's a sort of possibility that there might be something there. And that something comes out of energy. Like it's the material, energy equals to mass. Mass pops out of energy and then pops back into energy again. It sort of fluidly moves energy to material, back to energy again. Yeah, so this is the quantum vacuum energy. It means that in the emptiness of space, there is tiny, tiny fluctuations in the background energy, like a kind of, like you might say, very ripples on the surface of the ocean, which means that very small waves come in and out of existence, and that pops up into a particle, and then that particle disappears again. So quantum fluctuations mean there's a non-zero possibility of something existing. And then every now and again, of course, something does exist and then exists and then it pops off again. Yeah. So these kind of things just zipping in and out of, well, it's not reality. I suppose it's changing state from a pure energy into material form and back again. So that's the quantum vacuum energy that actually seems to permeate the entire universe. And it's very, very, very tiny. But if you add up the enormousness of space, actually you get a fair size number of a kind of background energy existing in the universe. So if you go kind of right back, actually you might think that the universe itself, the Big Bang, emerged out of one of these little fluctuations in the background of something even bigger, something like that. So things kind of seething away in the background, little tiny, tiny little fluctuations in the background of the zero sort of level of the universe. So the vacuum is not entirely empty, but contains a seething field of energy fluctuations. So it's just kind of getting our head around this idea of what the energy of the universe is like. We've got obvious things like planets and stars and galaxies and things which contain a lot of energy and it's bound up into mass. And then we've got the heat and the light which comes from a star and all that kind of stuff. But then we've got this, over the entirety of the universe, a fairly large amount of energy that's just seething away in the background in these quantum fluctuations. That, of course, is also permeating us. So we exist on the planet. Our planet is in space. Our planet is orbiting the sun. And everything that's going on out there is also going on here as well. So it's like this kind of background of energy of the universe is permeating the room you're in your body, and all of the world that we live in. Just a very, very tiny level. So now let's think about the different kinds of energy that we might find in our body, apart from this very, very minuscule quantum vacuum energy. So more obvious level, right? So we've got, just from a pure physiological point of view, Western science, right? So we've got chemical energy. So what chemicals do we take in? We take in chemicals through the food we eat. We take in chemicals through the air we breathe. And that all gets combined, in our lungs and our digestive system, and the chemicals produce various molecules like glucose and things, which we know release energy in the body. They power the muscles and all the business. So chemical energy, very much. We've got thermal energy. So thermal heat energy, right? So the body is warm, the body produces heat, and has a sort of background level of heat that it likes to keep for some of these chemical reactions to happen. So we have a certain level of thermal energy. We can view that if we got an infrared camera, like a night vision camera, we can see the heat, through a camera. The body has electrical energy. So the electrical energy most obviously travels in the nerves, right? So we have the neurons packed into bundles, which we call nerves, and down each individual neuron, we have a pulse of electrical energy. It's not quite like a wire, but it's kind of like that, right? So we have a pulse of electrical energy, movement of ions in and out of the cell wall. So we also have electrical energy in the connective tissue. So we have the nerves, but also then we have some of the tendons and ligaments and fascia around the body that also transmits very small currents of electrical energy through the whole system. And it's kind of like seen as one of the communication modes of the body, how different tissues communicate with each other and relate information. Yeah, so stretching, for example, creates tiny electrical currents in the fascia, and that is, kind of felt in the body. Mm-hmm. So the body is very electrical, has quite a bit of electrical activity going on. Of course, also the brain, right? Brain, big electrical producer, right? All the neuronal activity in the brain. The heart itself actually produces a very strong electromagnetic field, which you can actually sense using these detectors on the skin surface. If you had an ECG, you can in the hospital, then that's basically detecting the heart's electromagnetic field when it pulses. So that's also that. And then you could say the body has a fair bit of cool gravitational potential energy. I mean, saying makes sense, but basically the potential energy is the fact that if you stand at the top of the stairs and you topple forwards, the gravitational potential energy will pull you all the way down the stairs to the bottom. So that your body has a certain amount of potential energy in it for movement. And it's kind of like gravity, if you got to say, gravitational potential energy. We have mass, and we're standing up or sitting down, and if we fell down, that's what pulls us to the floor. So we've got all these different kinds of energy, just purely from the physics point of view. And as I say, energy, I would see it as a collective term. If I say my body is made of energy, or has energy, or moves in energy, then I'm referring to all these things like chemical, electrical energy, thermal energy, all that stuff together. So then if you look in the ancient Chinese and also the Hatha Yoga tradition, the Indian yoga tradition, they also talk about different kinds of energy. So let's talk about the Chinese, since that's what we're looking at today, the qi types of energy. So they call it yuan qi, primary qi. So you recognize Sue would always talk about our teacher Sue would often talk about this being basically the savings account of energy. So you're born with a certain amount of energy in our savings account, like prenatal chi, some people call it. Like we have a certain amount of chi. Some babies are born very strong, and some babies are born very weak. And then as we go through life, also we have certain sort of background level of energy in our system. My sister, about 10 years ago, hit kind of like energy bottom. She burned out very badly, and it's a very clear, horrible, but quite clear view of how someone can hit energy bottom. Like it's all gone, depleted. She depleted her savings account, and so it doesn't really matter how much energy she put in on the day. she was back to zero again, at the end of the day. And it's taken a lot of years to try to build that back up again. Takes a lot. Mm. So then we've got what the Chinese would view as the kind of chemical energy. They've got zongqi, which is basically the air that we breathe, and then yingqi, which is the food that we eat. So we would call that chemical energy. Yeah, we breathe, the food we eat. And then they also talk about wei qi, which is what you might describe these days as our immune system. They call it defensive qi. So, yeah, again, very linked to the energy of the body, whether we have enough energy to fight off colds or viruses, whatever, Yeah. So, integrity of the skin and digestive system, all that kind of stuff. So different kinds of chi. Then the way that chi moves in the body. So we have chi, which is stored in the organs. We have chi, which flows around the meridians. So, I mean, I've mentioned, I often say to people, right, so meridian is a very bad translation. I think when the Westerners first went to China and encountered this kind of stuff, it looked a little bit like they were talking about the meridians on the Earth, lines of latitude and longitude. So they used that word meridians. It's the wrong word. So the best word is channels. That's a direct translation of the Chinese mai or the Japanese myaku, the channel in the body. So the energy is accumulates in the organs or maybe generated in the organs and then also flows around the different channels. And, we have various channels in the body, all the different organ channels. We could perhaps say energy has the capability of flowing upwards, downwards. It has the capability of flowing outwards or inwards, or indeed in a spiral sense as well. So lots of different ways energy can move. We talk about energy getting stuck in different places. So maybe energy could get stagnant, as in it's not really moving enough, blocked in certain places. Energy can get rebellious, so as in like it's moving in the wrong direction, or there's too much of it in the wrong place. So there's kind of different views of that. And I think it makes a lot of parallels. I think, to our Western view, um, we can think about the body very much as things getting stuck. Certainly, like arteries, the flow of blood energy, right? This basic chemical energy can get very stuck, or the arteries get blocked, and we get heart attacks and all sorts of things. Yeah. So, yeah. There's anyone want to sort of chip in with anything at this point? And it's kind of making sense, or any thoughts or reflections or anything else?
Yeah, I really like the way that you've explained that, Mark. I think for me, I'm curious to learn a little bit about thought and vibration, thought
Hmm.
and energy. If we think about a thought, it's a quantum vibration, isn't it? I can have an angry thought, I can have a happy thought, I can choose my thoughts. So I'm curious along that journey if you
Yeah.
any light that you and Joe can share on
God, exactly. So that's right, exactly right. So thoughts can arise seemingly out of absolutely nothing. Like you just come up out of nowhere, don't they? They come out of you might say that kind of quantum background. Like it's just sort of fluctuating in the background and up pops a thought, and the thought can exist on a different well, yeah, you could use the word vibration, right? Or sort of like energy level. It could be high or low. It could be kind of like this way or that way, like a compassionate thought or an angry thought or, destructive thought, or it can be very swirly and high energy, or it can just be very almost like just imperceptible, isn't it? So we've got that whole um, physics doesn't really have anything to say about thought levels. Anyone else got any sort of thoughts about that?
There must be something to, though, thoughts as energy because they they almost generate fuel for the body. If you think about how when people are angry, the body will move in a way, in a sequence of shapes almost. And if there's joy, there's a different kind of unfolding of shapes. So it might be something that Western medicine will catch up to. I don't know about it in Chinese medicine though, because I don't know much about Chinese medicine. But
Yeah.
yeah, the
Just
great unspoken, the truth of the thought energy.
mm. Yeah, it's kind of interesting. You just made me remember actually there that the Chinese, they don't really see the brain as being very important in the view of the body. They see it as being basically on a level equivalent to the bone marrow. It's like a big piece of bone marrow in the head. And on the West we put the brain as kind of like center, like most important thing. But yeah, so like the thoughts, like for example, anger would be linked to the liver. We have an angry thought that's coming from the liver, that's generated by the liver. Or if we have a thought about or a feeling about grief, that's coming from the lungs. Or if we have a thought about connection and kindness and openness, that's coming from the heart, for example. So I think that they kind of they see those energies being formed and shaped by the organs themselves, and then they would have a view of the organs being forming a kind of community. And if the organs are all doing good, like functioning well, there's no problems, then they balance each other out. Like they all take a place, like like the state. They see a very parallel with the way that the politics work, so that the emperor and the ministers and the politicians and the people, kind of all just taking their place within it and making things work very well. So that would be the Chinese view of the thought world.
Thank you for that. Thank you.